is Unit 6 review for calculus. Okay, the first problem says the function f is continuous on the closed interval 1, 7 and has the values that are given in the table below. Use three subintervals. Using three subintervals, what is the trapezoid approximation of this integral 1 over 7 of f of x dx? So this means find the area under the curve from 1 to 7. We're going to use the trapezoid approximation using three trapezoids. So let's graph it just to give us an indication of what it looks like. Graphing. Okay, we get a curve that looks like this. So my trapezoid is going to go from 1 to 4. That's one trapezoid. From 4 to 6, that's 2. And from 6 to 7, that's the third one. So the area of the first trapezoid is going to be base 1, which is 33, plus base 2 times the height. And the height is 3. From 1 to 4 divided by 2. The second trapezoid is going to be 47 plus base 2, which is 48, times the height. And the height is going to be 2 divided by 2. And the last one is going to be base 1 plus base 2 times the height, which is 1, divided by 2. So as we add those all up, we get 499 divided by 2, or 249.5. Okay, number 2. If x squared minus 3x plus 2y squared equals 11, find dy dx. Okay, so we're going to have to use implicit differentiation. We're going to have to use the product rule in the middle. So u is going to be negative 3x. V is going to be y. So the derivative of u is negative 3. The derivative of v would be y prime. So we're going to have 2x minus the derivative of u times v plus the derivative of v times u plus 4y prime equals, this is going to be 4y, y prime. Okay, we're going to have 4y times the derivative of y. Okay, so we're going to factor out of y prime, so we're going to get 4y minus 3x. We're going to subtract 2 and add 3y. And then we're going to divide. So y prime is 3y minus 2x divided by 4y minus 3x. Okay, so if f of x is cosine to the 7th of x minus 2, what is the derivative? So we're going to use the chain rule. Okay, so this is another way of writing cosine x minus 2 squared to the 7th, sorry. So 7 cosine x minus 2 to the 6th times the derivative of the inside times the derivative of the inside. So we're going to have negative 7 cosine squared times sine x minus 2. So there's my derivative. 4. What is the x-coordinate of the point of inflection? That means I need the second derivative of the graph. So my first derivative is going to be x squared plus 8x. Second derivative is going to be 2x plus 8. We're going to set that equal to 0. Solve for x. So x is negative 4. And we can check just to make sure that that's the point of inflection. I have to check my second derivative. So to the left of negative 4 is negative 5, to the right is 0. So when it's 0, the second derivative is positive. When it's negative 5, the second derivative is negative. So that is the point of inflection. Okay. So what is the antiderivative of x minus 8 over x? So I need to separate these first. I need to write them as two fractions instead of one. Do a little bit of algebra first before I find the antiderivative. So I get 1 minus 8 over x dx. Okay. So the antiderivative of 1 is x. I'm going to bring the negative 8 down. The antiderivative of 1 over x is ln of x. And don't forget your plus c. Okay, find the area under the curve from negative 3 to 1 of the absolute value of x plus 2. So since I have no idea yet how to find the antiderivative of absolute value, I'm going to go ahead and graph this. So x plus 2 means that I'm going to go to the left 2, and I have the absolute value. So I'm going from negative 3 to 1. So I need to find the area under the curve. So it's basically two triangles. So the base here is 1. So it's going to be 1/2 base times the height. And the height, when x is 3 or negative 3, y is negative 1. So the height is going to be 1. The second triangle, the base is 1, 2, 3. Is when x is 1. So when x is 1, y is 3. So I'm going to have 1/2 plus 9/2. That's going to give me 10 over 2. So that would give me 5. So we're trying to find the total distance traveled by the car from 4 to 10. So from 4 to 10. So I'm going to cut this up into two rectangles. Okay, here's one, here's the other. So the first rectangle has a base of 4, right? 2, 4, and a height of 30. The second rectangle has a base of 2 and a height of 90. So I'm going to have 120 plus 180, which will be 300. So the total distance traveled by the particle would be 300 kilometers. Use the graph of the integrand and the area to evaluate the absolute integral from negative 10 to 10 of the square root of 100 minus x squared. Okay, so this is half a circle with radius 10. So the area under the curve would be a circle, which is pi r squared divided by 2, because it's half a circle. The radius, it's 10. So I'm going to have 100 pi divided by 2, or 50 pi. So that would be the integral from negative 10 to 10. Okay. Number 9 says a particle starts at x equals 0, moves along the x-axis with the velocity. Okay, so here's my derivative. For time t greater than 0, where is the particle at t equals to 7? So where is the particle means how much did it travel from 0 to 7? So that means the area under the curve, or the integral from 0 to 7 of 4x minus 3. So there's two ways to solve this. A, you can either draw a graph and find the area under the curve, or B, you can find the antiderivative. So I'm going to find the antiderivative. right? You add 1, divide by the new exponent. So I'm going to substitute 7. And if you substitute 0, that's going to give you 0. So that would give me 2 times 49 minus 21, which is 77. So the particle moved a total of 77 hours. Okay, number 10, evaluate. Again, we're just finding the antiderivative. So you're going to add 1, divide by the new exponent, subtract x, and don't forget your plus c because you're finding the antiderivative, not the area under the curve. Okay, 11, to find the antiderivative of this one, I'm going to first rearrange it to have it as negative 3. So then I can add 1, and divide by the new exponent. And don't forget your plus c. So this is going to be 5 over negative 2 x squared. And there's my antiderivative. Number 12, the integral from 6e to the x. So again, 6 is a constant, so you can just bring it down, or a coefficient. The antiderivative of e to the x is e to the x. And then don't forget your plus c. So similar to the other one, we're going to use the chain rule. So it's going to be 6 cosine subtract 1 times the derivative of the inside times 1. Derivative of